the real complication of the real atmosphere. The atmosphere is immensely complicated. Let me put it this way. What makes the atmosphere so complicated is the presence of water vapor. Water is a very, very important greenhouse gas, much more important than carbon dioxide. And it's one that we cannot control in any way. It's all evaporation from the ocean. There's no way to control that. And as you can see, let me give you one example of feedback. The models all assume that water vapor produces a positive feedback. That means that the water vapor amplifies the effect of CO2. We say that water vapor produces a negative feedback, which means it reduces the effect of CO2. How's that possible? Well, I'll tell you. Supposing we increase CO2, and that produces a certain amount of warming, which warms the ocean. When you warm the ocean, you get more evaporation of water. Okay? Puts more water vapor in the atmosphere. What happens to the water vapor? It produces more clouds, and eventually more rain. What happens if you produce more clouds? Well, you reflect more sunlight back out into space. Sunlight cannot get down to the ground to heat the ground. That's a negative feedback. It means that an increase in CO2 producing a slight warming will produce enough water vapor to offset the warming by increasing cloudiness. Now, of course, one has to prove that. It hasn't been done yet. On the other hand, they haven't proven that it's positive either. So it's an open question. Let me get to item number 3. I'll discuss all of these briefly and then come back to number 1, which is the important one. Item number 3. Okay, if it isn't carbon dioxide that's causing climate change, if it isn't human activities, what is causing climate change? What are these natural factors? There are two possibilities. One is that there's an oscillation of the atmosphere and ocean. That's an internal matter. And the other one is external. What could that be? And the answer is, again, the sun. The sun is not a constant star. Its emission does not remain constant with time. It varies. There's a sunspot cycle of 11 years. There's another cycle of 22 years. There's a cycle of 80 years. There's a cycle of 200 years. There may even be a cycle of 1,500 years. There are all kinds of oscillations within the sun that change the output of the sun and thereby affect the climate of the Earth. Do we have evidence for that? The answer is yes, we do. I will show you evidence that demonstrates conclusively, I think, others may not agree, but I think conclusively that changes in solar activity affect the climate. It's based on published papers, not by us, but papers that are in the literature that clearly demonstrate this. And you might ask, well, why doesn't the IPCC, the UN group, reach the same conclusion that we do? And the answer is they ignore it. It's a very funny thing about scientists. If you have a hypothesis, some scientists, if they find that the observations, the evidence goes against the hypothesis, they tend to ignore it. It's a human characteristic. I think we're all have this problem. We tend to ignore things that are unpleasant or that we don't want to have around. And in our business, the climate business, it's very easy to ignore things. There's so much going on that you just say, oh well, can't be right. Must be something wrong with it. So let's ignore Item number 4, I will just mention, I won't discuss it. There's this controversy going on right now on this item, and it means the following. It says, supposing we stopped increasing carbon dioxide, supposing tomorrow, starting tomorrow, we stop burning fossil fuels, and carbon dioxide would stop increasing. What would happen to the climate? Many scientists believe, but I do not, that the climate will continue to warm because of heat stored in the ocean. That's a problem in physics. And I think it'll be settled by arguments. Physicists will argue about this, and I hope we'll settle it. Item number 5 is a very important one. Item number 5 deals with the data. The data that we have are not very good. We have data, temperature data from the surface of the Earth based on weather stations. We have data from balloons carrying radiosols that measure temperatures in the atmosphere. And we have data from satellites looking down on the atmosphere and the Earth. I tend to believe that the satellite data are the best, but I'm prejudiced. Why do I think so? Well, because satellites observe the Earth day in, day out, on a continuous basis, and have complete geographic coverage from pole to pole. Balloons don't have that. The balloon data are obtained from weather balloons that are launched from weather stations. And weather stations, of course, are mainly on land areas. How much of the Earth's surface is covered by land? 30%. 70% of the Earth's surface is ocean. We don't have any good data from ocean, from the atmosphere over the ocean. Also, balloons have other problems, balloon data have other problems, instrumental problems. Let me not go into this. The worst are the surface data. The surface data come from weather stations. Well, you'll think that that's an easy thing. Unfortunately, that's not true. The weather stations are badly placed and subject to all kinds of errors that have not been corrected. A recent report showed that in the United States, some hundreds of weather stations are located near exhausts from air conditioners, near buildings that put out heat. In other words, they're subject to local effects. They're not measuring global temperature. To make matters worse, in the last 20 years, about half of the world weather stations have been eliminated. I'll come back to that in a minute. Item number 6, very difficult one, and very much disputed. Supposing, again, as I mentioned earlier, you suddenly stopped emitting carbon dioxide. What would happen to this surplus that's built up over the last 100 years? We all know it would decay. And eventually you'd be back to the situation that you had before the Industrial Revolution. The question is, how long would it take to decay? Okay, some people say 5 years, some say 3,000. When I say they say this, I mean they've published it in refereed papers. These are scientific results. How can there be these vast disagreements? Well, there are. They are. I happen to believe that both numbers are wrong. The situation is complicated by the fact that the ocean absorbs CO2, but also emits CO2, depending on temperature. CO2 is soluble in water. But the solubility depends on temperature. You've all, of course, known that you have some soda pop and you warm it up, the CO2 will disappear. All the bubbles go away. If you keep it cold, the CO2 will stay in the water. You have the same situation in the ocean. That has not been handled properly. The next item is abrupt climate change. All the climate models show that the climate will warm gradually as carbon dioxide increases. It's a smooth effect. However, there are people who are concerned the climate may change abruptly and flip into a new regime. And we've seen this happen in the past. During the last ice age, which was 100,000 to 10,000 years ago, when much of North America was covered by ice, we know that there were sudden changes in temperature about every 1,500 years, probably produced by the sun, by some solar effect. These effects were discovered only about 30 years ago by a Danish scientist, Dansgaard, and the Swiss Oeschger. So they're called the Dansgaard-Oeschger events, DO events. We think we also see them in the Holocene, which means in the last 10,000 years, the warm period between ice ages. You know, of course, that we've had 17 ice ages in the last 2 million years. We fully expect to get another ice age soon. We don't know when, but soon. How do we know? Well, just from the past. Usually these interglacials, the warm interglacials, last only about 10,000 years, and we've had the Holocene, a warm interglacial, for about 10,000 years. So it's about time for another ice age. Some of you in this audience, some of the older ones, I would say, may remember that in the 70s, which is only 30 years ago, or 40 years ago, there was great concern about a coming ice age. Books were published. Time magazine, Newsweek ran stories about the disaster of a coming ice age. Why? Because temperatures were falling at the time. Well, temperatures have been falling for the last 10 years now. So there's again concern about a coming ice age. And believe me, if temperatures keep on decreasing as they are now, I'll show you in a minute, you will see headlines again about a coming ice age. There's always some disaster, coming. It's either swine flu or avian flu. Now it'll be a coming ice age. There's some interesting scientific problems connected with this abrupt climate change issue. And they'll be discussed here at Ohio State next month in June. I may come out for that, or I may not, I don't know. It's a matter of time. We'd like to understand why it is that the Dansgaard-Oeschger abrupt changes were large during the Ice Age, and why they're so small in the Holocene. One has to set up a hypothesis and try to test it. Lastly, and most important, we have sea level rise. I think you all know that of all of the climate issues people discuss, sea level rise seems to be the one that excites people the most. Not temperature, not drought, nothing. Not even polar bears. Sea level rise, that's what people are concerned about. I'll try to show you something about sea level rise because it's such an important issue. And you will feel better after you see the data, believe me. There's nothing to worry about. There's been no acceleration in sea level rise in the last few thousand years, in spite of temperature changes. We expect no acceleration in the future. Sea level will continue to rise as it always has for the last